All of the equations in the previous lessons have had one solution. There are equations with more than one solution. Some examples of these type of equations are equations where variables are taken to powers, or where we need to take square roots of variables, or where variables are inside absolute value symbols. We'll deal with some of those types of equations in subsequent lessons. But in today's lesson, we're going to look at equations where every real number is a solution, and also equations that have no solutions. Here's our first example. We've got the distributive property required on both sides, so we apply it. We get 6n plus 12 equals 6n plus 16. So we want to get all the variables on the same side. We add negative 6n to both sides, but something different has happened. We have a pair of opposites on each side, and there's no variable terms left. We're left looking at 12 is equal to 16. This, of course, is false. And since this is false, we have now figured out that there's no solution for this equation. You can write the words no solution, but you can also use this symbol, a 0 with a slash through it. It does not mean that 0 is a solution. It's called the empty set symbol, and it means that there is no solution for this equation. Here's another one. Looks pretty similar to the first one. We apply the distributive property again, but now we have the exact same thing on the left side as we have on the right side. If we want to go a little bit further, we could go to the trouble of adding negative 6n to both sides. We get 12 is equal to 12. We could even add negative 12 to both sides, which would give us 0 is equal to 0. But I think we've gone far enough. We know that 12 is equal to 12. This equation is true. So in this equation, every real number is a solution. There's a special name for this type of equation. It is called an identity. When solving an equation of this type, once you know that it's an identity, you may just write the word identity. But there is a shorter way. Just write a big script capital letter R. This symbol stands for the set of all real numbers. And if you write it when solving an equation that turns out to be identity, you're letting everyone know that all real numbers are solutions to this problem. Here's one more example. We apply the distributive property again, and we get that 6n plus 12 is equal to 8n plus 12. Now we're going to add negative 6n to both sides, and we get that 12 is equal to 2n plus 12. So the variable term did not go away. But then when we add negative 12 to both sides, it's the numerical term that goes away. But don't forget, as we talked about in an earlier lesson, on the left side, when there's nothing left, we need to write the 0. And now we divide both sides by 2. And while we can't divide by 0, we can divide into 0. In this case, 2 into 0. And of course, 0 divided by 2 is 0. So this equation does have a solution. The solution is 0. I bring it up in this lesson because sometimes when the solution is 0, problem solvers get confused and they think that there is no solution at all. Let's do 3 more examples. A little more complicated, this one. We'll apply the definition of subtraction. Then we'll apply the distributive property. We're going to show a little less work now. We're still showing work, but we're not showing as much work. But from line 1 to line 2, I hope it's clear that we've used the distributive property to get negative 2 times 1 to make negative 2, and negative 2 times negative 2k to get 4k. We now combine like terms. The 6 and the negative 2 makes 4, and now we've gone far enough. It's clear that 4k plus 4 is equal to 4 plus 4k. If you want to go to the trouble to add negative 4k to both sides, you can. But this one is clearly identity, so we'll stop here. We'll put the script R that tells us that all real numbers are solutions to this problem. Here's another example. Apply the definition of subtraction again. Apply like terms. And now we're going to get rid of the 7s. We're not going to show the work, but there's a 7 on each side. We get rid of it. At the same time, we're not showing as much work, but what we have done is we've added 5h to both sides, and 4h plus 5h is 9h. But remember, when nothing is left on the right side, we need to put the 0. We divide by 9. Didn't show it, but we know we did it. 9h divided by 9 is h. 0 divided by 9 is 0. That's our solution. H is equal to 0. And in our final example, we'll start by applying the definition of subtraction, then the distributive property, then we combine like terms, then we get rid of the 6s on each side, leaving us with the statement that -2 is equal to -4. That's false, so there is no solution, and we write the empty set symbol. To summarize, an equation that has every real number as a solution is called an identity. A capital letter R means all real numbers. The empty set symbol, shown here, is often used for equations with no solution, and some equations with a solution of 0 can be confused with equations that have no solution.